A musician released a new song on a streaming service. The streaming service is an online entertainment source that allows users to play music on their computers and mobile devices. Several months later, the musician began using the app at t=0 that counts the total number of plays for a song since it was released. A play is a single stream of a song on the streaming service. The table gives the total number of plays in thousands for the selected times t months after the music began playing using the app. At t=0, the total number of plays was 25,000. And so you can see they simplified it by writing 25 and over here saying thousands. At t=2, the total number of plays was 30,000, and at t=4, the total number of plays was 34,000. The total number of plays in thousands for a song release can be modeled by the following function, where d of t is the total number of plays in thousands for the song since it's released, and t is the number of months after the musician began using the app. Let's get started. So for the first one, we are going to create 3 equations. And so I'm going to create the equations with what I see. This is my input in time, and this is my output. So I'm going to come to this equation. My input is going to be 0. My output is going to be 25. So for the first part of A, I have 25. And if you wrote 25,000, I'm going to leave it in this form. 25 equals, and then I have A, 0 squared, plus B times 0 plus C. Then I have 30 equals A times input is 2. 2 squared plus B times 2 plus C. And lastly, I have 34 equals A times 4 squared, B times 4 plus C. That's 1 point. Let's go to the second part of A. For the second part of A, we want to find all of the values. Okay, so this is a calculator. FRQ2 is a calculator-related problem. And so what I'm able to do is I should be able to use this regression model. And so what I'm going to do is I'm going to clear my calculator, and I'm going to go up to stats, and I'm going to input the information. So I have 0, 2, and 4 in inputs, and then my L2 is 25, 30, and 34. I'm going to go stat. I can see this is a quadratic function. Stat, calculate, and go down to quadratic regression, printing enter all the way through, and there's my answer. So for the second part, I have A is approximately negative 0.125. B is not approximated. B is going to be a terminating decimal of 2.75, and C also is 25. I don't want to use these squiggly equal signs if it doesn't appear to be. You know what? I'm even going to say that this looks exact. This does not look like it was a rounded value. There's your A, your B, and your C. Let's move. For part B, it says, and you're going to see for FRQ2, you're going to see the same type of pattern with all the questions. It says, we want to find the average rate of change of the total number of plays of the song in thousands per month from t=0 to t=4. So I'm looking at 0, and I'm looking at 4, and I'm looking above. 0 goes with 25,000, and 4 goes with 34,000. And then I'm going to use that y sub 2 minus y sub 1 minus x sub 2, x sub 1. Within this, it does want to see your computations that lead up to your answer, so 34 minus 25 over 4 minus 0. So I end up with, on my calculator, with 9 halves. Could I leave it like that? I could. Could I turn it into, into a decimal? I could also do that. So I'm at 2.25. Now, I think it's important because I can't tell based on the scoring guide if you have to make sense of this. So let's just come back up here. It says find the average rate of change. So 2.25. I'm just going to write the average rate of change from t=0 to t=4 is 2.25. And I'm just going to write down exactly what it says. Total number of plays for the song in thousands per month. And that's just guarantee me. It's possible just this or just this is enough. In equivalent fraction or a decimal form, you only have to write once. But based on what I see in the scoring guide, I think I'd add in one extra bit explaining what that means. Okay, let's go. Right, so now this second part of B, it sometimes says, hey, use a specific extra point. we are going to come up with a linear equation. And it says, hey, use the slope from up above. So that went from 0 to 4, right? So from 0 to 4, we created the average rate of change, and that was 2.25. So I'm going to replace m with 2.25. And then I'm going to choose any value, so 0, 25, 230, 4 to 34. But I could choose any one that's within this to choose what is my b value. But what I know is I know that the easiest to use is whenever you're given x equals 0, it makes it really easy. Makes it easy because 0 times 2.25 is 0. That means 25 equals b. And now I have this equation, y equals 2.25x plus 25. Okay, what do they want us to do with this? They want us to use this equation that was formed using the rate of change from the original section, and they want us to test it at 1.5. So I'm going to replace my x right now with 1.5, and I'm going to grab a calculator. 2.25 times 1.5, making sure to have this down, plus 25, and there we go. Okay, so we have, this is approximately 28 point, maybe that is exact. That appears to be exact. This appears to be exact. Exactly 28.37 thousands of songs. Again, what does it mean? Express your answer as a decimal. We see the computation. We're looking for using this average rate of change. We're talking blah, 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 blah. Yep, okay. We got that all down. The total number of plays for a song. So this is the total number in thousands of plays for a song. I just went back in and found out exactly what did that mean within the context of the problem. Now this third part, it often gives students trouble. On this third part, when we're looking, it says that if we use this equation, which we were able to form using the average rate of change in part 1, and we came up with the equation in part 2, if we calculate using that formula, if we calculate a of 1.5, we can see we ended up with approximately 28.375 thousands, right? Thousands of plays per song. Now, if we take this formula, and you're like, where do we get this formula? Well, it gave us this basic formula we could use, and then in this part, we actually calculated the A, B, and C. So here it is right here. And if I plug it in and I graph it, now when I look at this, I'm going to actually do it at 1.5 because it says this at 1.5 we're going to compare the two, okay? So we're going to plug in 1.5 representing a month and a half after a song is released into this first formula using average rate of change, so it's going to be this linear line. Or if we use this quadratic that appears to be an upside down or a parabola that opens downward, let's get a look at this. Okay, so I'm only going to go from 0 to 3. You could do 0 to 2, just anywhere past 1.5. And I'm going to do a zoom fit. Second calculate value, and I'm typing at 1.5, okay? And so D of 1.5 is approximately 28.844. Okay, we can see that they are very close, and I would write this down, but this is true. A of 1.5 is less than D of 1.5. Now, why is that? That's going to be the next part. The next part says, explain why this is the case between 0 and 4. Well, let's just look from 0 to 4 right now. Let's just take a look at this from 0 to 4. Okay, I got to get this and do a zoom fit. So from 0 to 4, we're working with the parabola that, yes, it's opening downwards, right? But this parabola is going to be above that secant line. So if I went in and I actually typed in this equation here, this equation would be 2.25x plus 25. You can see that the D of t is going to be above the secant line, which is in red, between 0 to 4. So how do I go ahead and I explain that? Okay, so we're explaining it at the specific point. So from t equals 0 to t equals 4, D of t is a parabola that opens downward and is above the secant line created from A of 0 to A of 4. And I think I'm actually just going to draw a picture here of what I see. I'm going to draw a picture here of what I see. So we have this is D of t. We're going to label it, and this is A of t. Okay, so we can see we have D of t has a decreasing rate of change, thus it is concave down. Oh, yep, concave down on the interval from 0 to 4. Let's take a look at C here. We have a quadratic function, and so I've gone ahead and actually graphed this. And it says it has exactly one absolute minimum or maximum. We can see this has a maximum, and that minimum or maximum can be used to determine the domain or the restrictions of the domain, which means the end point. You can say it can go up to this amount. Based on the context of the problem, explain how the minimum or maximum can be used as a boundary. Okay, I need to come back up here and just make sure that, give me 1 second. I want to make sure that T is in terms of months. Okay, so when I look at this, let's calculate what is this maximum. So I go slightly to the left, then I come back slightly to the right, and then back to that point. There we are. Okay, so we can see that this maximum occurs at 11. It's the X value. And so remember that we were told that D of t represents the total number of plays in thousands of a song since it was released in the app, and it cannot be negative. So it must be positive, and it will not be decreasing. That means it must be going up and positive. Well, all of this part right here is going up. It's increasing. And all of this has a positive Y value. So this is the section. In this problem we asked, is there a boundary in the domain? That means that it goes up to what point? Since we know that it can never be decreasing, we could say that the boundary is, or the right boundary of the domain, represents the max value when t, not x, when t equals 11, since D of t must be positive and increasing.